Hi students, welcome to part 2 of chapter 6.1 notes. In this chapter, we will be looking at how to expand binomials with one of the terms being 1 and the other term being any term. So today I'm going to show you how to use the binomial theorem, alright, to expand simple expressions such as 1 minus 2x to the power of 5, just as an example. Okay, so how do we use the formula? Okay, I'm just going to briefly go through. So you can see that if I have 1 plus b raised to the power of n, where n is a positive integer, okay, what we'll do is we will have the first term being 1 plus n choose 1 b. Okay, in this case b is raised to the power of 1, okay, plus n choose 2 b raised to the power of 2 plus n choose 3 b raised to the power of 3, so and so forth. Okay, so if you were to spot a bit of pattern, you should realize that the r term corresponds to the power of b in this case, which is basically your second term. Alright, so in this case, the last term will always be b raised to the power of n, which is your original power. Okay, so this may seem a bit complicated, but I'm going to show you how to make use of this formula in the subsequent examples. Okay, so let's look at what example, try it 5. Okay, so the question gets us to expand the first three terms of 1 minus 2x to the power of 5 and 1 plus 3x to the power of 9, okay, in ascending powers of x. Okay, so basically ascending powers of x just means that the powers of x will be increasing from smaller to bigger. Okay, later when we expand, you'll be able to see that the power does increase. Okay, so the first thing you need to do is applying the formula. The first term, if the first term is 1, this will always be 1. So 1 plus 5 choose 1. Second term raised to the power of 1. Okay, 5 choose 2. Second term raised to the power of 2, so and so forth. Alright, as you can see, I stop here because the question only gets us to expand to the first three terms. So this is your first term, second term, and third term. Okay, so you do not need to expand anything beyond that. So to show that there are more terms at the back, I'm going to use this symbol plus triple dot. Okay, so this symbol tells us that there are still more terms at the back which we will neglect in this case. Okay, so we will simply simplify the coefficients. So for example, right, how did we get negative 10? Okay, how did we get negative 10? Okay, I'm just going to simply work this out using a calculator. So you can see I'm going to press 5 choose 1 multiply by negative 2. Alright, so that gives me negative 10. Okay, and then work out the second term. 5 choose 2 times negative 2 to the power of 2. Okay, so this part here, take note, you are using law of indices. So you should get something like that. Okay, so I'm just going to key in again. 5 choose 2 times negative 2 to the power of 2. So that gives us the number 40 that you see over here. Alright, so now do the same for 1 plus 3x to the power of 9. Simplify it and you will get 1 plus 27x plus 324x squared. Okay. Alright, the next part. The next part requires you to find the expansion of these two terms which you have expanded earlier up to the term in x squared. So what do they mean? Okay, so basically they want you to multiply the individual terms that you have obtained earlier together until you obtain terms that has a maximum power of x squared. Okay, so what I'm going to do is replacing 1 minus 2x to the power of 5 with what I have obtained over here, 1 minus 10x plus 40x squared. Okay, and replacing 1 plus 3x to the power of 9 with 1 plus 27x plus 324x squared. Okay, what I'm going to do is now I'm going to multiply term-wise, okay, and ensuring that I get, okay, the maximum power x squared. Okay, so I'm going to do the rainbow method. Follow me using the pink arrows. 1 multiplied by 1, 1. 1 multiplied by 27x, positive 27x. 1 multiplied by positive 324x squared, positive 324x squared. Okay, so I'm using pink color to show that this is the expansion for the pink arrows. Okay, next moving on to the second term, minus 10x. Okay, using purple arrows, minus 10x should multiply to 1. That gives you minus 10x. Minus 10x multiplied to 27x. So that gives you negative 270x squared. Okay, so let's think. Do we multiply negative 10x to 324x squared? Okay, no, we shouldn't, right? Because if I do so, I will have x multiplied by x squared giving me the x cubed term, which is not required by the question. Okay, so I do not proceed to multiply negative 10x and 324x squared. Okay, and last term, 40x squared, I multiply to 1. Alright, so that gives me 40x squared. Okay, so simply adding up all of the like terms, I should get this answer. 1 plus 17x plus 94x squared. Next example, try 5. Okay, the question again wants us to find the first three terms of 1 minus x to the power of 6 and 1 plus 4x to the power of 7. Okay, so using my binomial theorem, okay, start off the first term 1 plus 6 choose 1, the second term negative x raised to the power 1. Okay, 6 choose 2, negative x raised to the power of 2, so and so forth. Okay, so likewise, first three terms, please highlight. Okay, so do not need to expand beyond this. Okay, simplifying, you should get 1 minus 6x plus 15x squared. Okay. Likewise, for the second term, 1 plus 4x to the power of 7. Okay, using binomial theorem, I'm going to expand and I should get something like that. Okay, simplifying, I should get something like that. Okay, so there's no issues. Very easy and very straightforward expansion. Just make sure that you apply the laws of indices here. So this part here, please take note, this is 4 squared times x squared. So you should key into the calculator 7 choose 2 times 4 squared, and that should give you 336x squared. Okay, so please be careful for terms like this. Alright, so likewise, the question wants us to find the expansion of these two terms up to the term in x squared. So this question is exactly the same as the previous one, okay, where you have to use the terms that you have obtained from part 1 and multiply them term-wise to the other expansion, okay, until you get the x squared term. Right, so I should be focusing on this expansion. So 1 times 1, 1 times 28x, 1 times 336x squared. Okay, negative 6 should multiply to 1. Negative 6x should multiply to 28x squared. Sorry, 28x, and that should give me the x squared term. Lastly, 15x squared should only multiply to the constant term 1. Okay, because anything beyond that would give me a term that is larger than x squared. Okay, so that should give me this expansion, and finally this answer. Alright, so please pause the video and try these questions yourself before you look at the answer. Okay, I highly recommend that you work it out yourself first before you double check your workings with me. Okay, moving on. Okay, example 5. Obtain the first 4 terms in the expansion of 1 plus k raised to the power of 8 in ascending powers of x. Okay, so the first part is very straightforward. Using binomial theorem, expand this for the first 4 terms. Alright, so I'm going to show you the first 4 terms, 1 term, 2 term, 3 term, 4 terms. Okay, so to be precise, I should have k to the power 1 here. Okay, Next, simplifying this, okay, just working out the coefficient, binomial coefficients, okay, of 8 choose 1, 8 choose 2, 8 choose 3. Using your calculators, you should be getting 8, 28, and 56 respectively, okay. Okay, the next part requires us to do this. They said, hence, find the coefficient of x cubed in the expansion of this. So now this is no longer a binomial. This, in fact, is a trinomial, right? Tri because there are 3 terms, and we should not be expanding it forcefully, okay? Because we did not learn a method to expand 3 terms like that. Okay, we only know how to expand 2 terms, right? So I want you to make a comparison between this and the expansion in the earlier part. Do you notice that their powers are exactly the same? Both are raised to the power of 8. The first term is also 1. Okay, so that makes the only difference between the 2 expressions, k and x minus 2x squared. So in this case, what I can do is I can, okay, replace k by x minus 2x squared. So all of the k terms that I have earlier, all I need to do is just to replace them by x minus 2x squared. Okay, and from there, we will only expand terms that allow us to obtain x cubed, because I want the coefficient of x cubed. So any other terms, the constant term, the x squared term, the x power 4 term, so and so forth, I'm not interested. I only want x cubed. Okay, so the first step, I'm going to replace all of my k's by x minus 2x squared. Alright, so these are all my replaced terms. Okay, next, I'm going to be very selective. Look at the terms, the first 2 terms on the left. Okay, clearly these terms does not contribute to the x cubed term, okay, because 8 times x is 8x, and then this is negative 16x squared. There's no x cubed term, so I can ignore these terms, right? So I'm just going to leave it as plus dot dot dot. Okay, so I'm only interested in this part. The action only begins here and here. Okay, so using your a minus b squared formula, a minus b squared equals to a minus 2ab plus b squared, I'm going to expand x minus 2x squared. Okay, so this will give me this term over here. Okay, and if I were to expand x minus 2x squared raised to the power of 3, okay, I'm only interested in the first term, which is the x cubed term. Okay, how do I know that the first term gives me x cubed? Okay, so if you want, you can write it out like that. X minus 2x squared multiply itself 3 times. Okay, so using rainbow method, x times x squared times x cubed. Okay, subsequently, x multiplied by any other terms will give you terms with power greater than 3. Okay, so that's why I do not want these terms. I'm going to ignore these terms. So I'm only interested in the first term obtained from the expansion of these 3 x's. So that's why I have my first x cubed term. Okay, so the coefficient of x cubed is none other than 28 multiplied by this term here. Okay, so this term here gives me my x cubed term, because x times x squared is x cubed. Okay, so I'm going to include the coefficients, just the numbers, right? 28 times negative 2 times 2. Alright, plus 56, because 56 will be multiplied to x cubed, and the coefficient of x cubed is 1. So 56 times 1, 56. Alright, so working this out, I should get negative 56. That's the answer. Okay, so you can pause the video here and rewind if you need okay, me to explain again. Alright, example 6. Write down the first three terms in the expansion in ascending powers of x of this expansion. Okay, so first three terms using binomial theorem again. Raised, okay, I have 1 plus 6 choose 1, 2x raised to the power 1, okay, 2x being the second term, okay, 6 choose 2, 2x raised to the power 2, okay, and that's about it. So just simplifying this, I should get 1 plus 12x plus 60x squared. Okay, so I'm just answering the first part. So this is a very straightforward part. For part 2, they are saying that if 3 minus x is multiplied to 1 plus 2x to the power 6, gives me these terms on the right. Okay, they want me to find the values of a and b. Okay, so what am I going to do in this case? I am simply going to replace 1 plus 2x to the power of 6 by the terms I have obtained earlier, the first three terms of the expansion as required by the question. Okay, so I will get something like this. Okay, 3 minus x times this equals to this. Okay, so how do I find the values of a and b? Okay, I'm just going to use the method of comparison. Okay, I'm going to compare the coefficients of the x terms on the right and the x terms on the left. Okay, so let's see, how do I get the x term? Okay, I would have to use 3 multiplied by 12x. Okay, that gives me the x term. And then negative x multiplied by 1. Okay, so these two terms with their coefficients added together should be equals to a. Right? So there we have it, 3 times 12 plus negative 1 times 1, okay, equals to a. So all I need to do is just work this out using your calculator, and I have a to be equals to 35. Alright. Lastly, to solve for the value of b, I will be comparing the coefficients of x squared instead. Okay, so I'm just going to erase the green arrows. Let me remove them. Okay, so now let's see how we can get the x squared using the expansion. So 3 should be multiplied to 60x squared. Okay, so a constant multiplied to an x squared term, you get the x squared term. And of course, the x term should be multiplied to another x term to give you the x squared term. So negative x times 12x. Okay, there should be nothing else. Okay, because any other expansion will give you a term that is not x squared. Okay, so as you can see, 3 times 60 plus negative 1 times 12. Alright, that will be equals to 12b. Alright, so all I need to do is to simplify the left side. 168 equals to half b, and then multiplying both sides by 2 to solve for b, and b would be 336. Alright. Okay, let's move on to the very last question. Okay, this is example 7. Okay, so I deem this question as challenging because the power of n is an unknown. Okay, so let's see how we can expand this. Okay, we should expand these terms accordingly depending to what we have on the right side. Okay, the question didn't tell us to expand to the first 3 terms or 4 terms, but how do we know how much to expand? Okay, I look at the coefficients on the, or rather the terms, the maximum power of the term on the right. So the maximum term is x cubed, so I should expand to the x cubed term on the left. Okay, so I will have something like this. 1 plus, in this case n is an unknown, so I'm going to leave it as it is. N choose 1, kx, which is the second term, raised to the power 1, and choose 2, kx squared, and choose 3, kx cubed. Alright, so simplifying this, I should get something like that. Okay, looks a bit complicated. Let me explain. This yellow term is your n. Okay, your n choose 2 is basically your n times n minus 1 over 2 factorial, and your n choose 3 is your n minus 1 times n minus 2 over 3 factorial. Okay, let me just explain this in case you didn't catch it earlier. Okay, let me just explain how do I get this from n choose 2. Okay, the rest should apply the same for n choose 1 and n choose 3. Okay, so n choose 2, based on the definition on n choose r, it says that this is n factorial over r factorial times n minus r factorial. Okay, so if r is a number 2 now, okay, I'm just going to replace my r terms with 2. Okay, so this will be n factorial over 2 factorial times n minus 2 factorial. Okay, and based on the definition of factorial as indicated in the part 1 video, okay, n factorial means you multiply n times the next preceding term is 1 lesser, okay, then times n minus 2 all the way to 3 times 2 times 1. Alright, and then for the denominator, I have my 2 factorial, and based on the definition of factorials, I start off with n minus 2, and then I multiply all the way to 3 times 2 times 1. So each term that comes after is always 1 lesser than the one before. Okay, what do you notice about these two highlighted blue terms? Isn't them the same? Right? They are completely identical. This is none other than my n minus 2 factorial. Right? So this cancels out. Okay, so that leaves me with n times n minus 1 over 2 factorial, which is what I have over here. Okay, so I'm going to do the same for n choose 3. Okay, you can work it out yourself. You should be able to get this. Alright, and simplifying, okay, I'm just going to combine the k squared, the k, and the k cubed terms together with the numerator. Okay, and then work out the 3 factorial and 2 factorial values, which is 2 and 6 respectively. Okay, so now what I'm saying is that the terms on the left is equals to the terms on the right. Okay, so I'm going to compare coefficients like what I did just now. Okay, so the first thing to compare is the coefficients of the x term. So 20 must be then equals to nk. Okay, that is equation number 1. And then equation number 2, we obtain it by concluding that the coefficient of the x squared term is equals to 45k squared. Okay, so dividing both sides by k, n times n minus 1 over 2 is equals to 45. Okay, then now I'm going to solve this very simple quadratic equation, multiplying 2 on both sides, okay, subtracting 90 on both sides, doing my cross method. Okay, I get 2 factors. Okay, using my zero product principle, I conclude that n plus 9 equals to 0 or n minus 10 equals to 0. Therefore, n will be negative 9 or n equals to 10. And in this case, I have to reject negative 9 since n is an integer that is larger than 0. Okay, so now knowing that n equals to 10, I have solved one of the unknowns. I can substitute it back into equation 1 to solve for k. Alright, and that's what I'm going to do. So 10k equals to 20, and then finally k equals to 2. Right? Lastly, we mustn't forget about the last term, our p term. So the p term being the coefficient of x cubed must therefore be equals to n times n minus 1 times n minus 2 times k cubed over 6. Alright, so these two orange terms will be equal. Okay, so I say that this is equation 3. Using the values of n and k, which I have found in the earlier parts, okay, n equals to 10 and k equals to 2, I'm going to substitute back into the left side to solve for p, right? So p is none other than just 960. Okay, and this concludes this video. Okay, please try the questions on your own. Okay, please let me know again if you have any issues. All right, thanks.